I'd like to go over the basics of using Repetier host, the SolidDoodle specific version 0.85b. First of all, this is not the most recent version of Repetier host. This is the one that SolidDoodle ships with their machines presently. They ship it with all the custom settings already programmed in, so you don't have to worry about setting traverse speeds, extrusion rates, so on and so forth. We'll work towards updating this in the future, but for now this will work perfectly fine for printing out objects that you have. So anyway, the first thing you need to do when opening up Repetier host is make sure that your 3D printer is both powered up and plugged into USB. Before you even start the program, they communicate through a serial port, which is a virtual one created through USB. If you question whether or not it's actually plugged in correctly, you can always click on printer settings. Up here mine says virtual printer because I'm doing this from a machine that doesn't have a SolidDoodle attached. You'll see COM3 down here. It should say COM3. You don't have to check that every time. Really all you have to do is sit down and click connect, and you'll see that it'll be communicating with the SolidDoodle printer. You'll say connected. Down here you'll see the extruder temperature and all the way down to probably the print bed temperature as well. The next thing you need to do is just load your STL file. As far as I know, STL is the only input format. It's the only one I've seen that Repetier host can handle. So I'm going to use the queen top part of the chess piece here. You notice it came in at an angle. That's okay. The coordinate system was different between Repetier host and SolidWorks whenever we saved it. This is maybe a situation, if that really bothers you that it doesn't come in perfectly level at the beginning, you can set up a secondary coordinate system inside of SolidWorks, like we covered with reference geometry. This would be an instance where using a secondary one could help you. However, it's very easy to fix. I'll simply rotate this 90 degrees in X by typing it into this window over here, and it's flat. I'll change the scale to 0.75 because the part was a bit bigger than what I wanted. Scale of 1 will save it exactly as you saw it in SolidWorks. You should save the STL files in millimeters. That's what comes in here. As far as I know, each one of these grid points is 10 millimeters. It's a centimeter. So this represents the 8-inch by 8-inch build platform that we have on the SolidDoodle machines. Okay, so 75% scale to match the rest of the chess piece parts that I'm printing out. I didn't want to make it full scale because it would just take forever. Notice how this is kind of off center. If I wanted to center objects up, I could do so. Also, if I want to print more than one thing at once, I can do that as well. Let's load up part of the king part. Yes, so now we have both king and queen. I can select the king part itself and rotate that independently, scale that piece independently. But now notice it's overlapping. I can right click on the screen and move it around on the build platform. But say I wanted to be a little bit more precise than that, you can do a button down here called auto position. It'll position those two pieces, or 3 or 4, or however many you want to print out at once, in a grid pattern on the build platform. To rotate views, I'm simply left-clicking on the window and moving the mouse. To zoom in and out, I'm using the mouse wheel. To pan up, down, left, right, I'm clicking the mouse wheel and moving it around. And then to move these parts, that's a right-click. So auto position looks fine. I'm just going to set up a one-part print this time. I just wanted to show you that you could bring in multiple in a single print. So center, great. Next step will be Slicer. Slicer is the software that takes the STL file, cuts it into all the various layers, and then generates what's called G-code for the machine to follow to lay down plastic traces. So it controls the speed of the machine, the location of the machine, so on and so forth. You'll actually be able to see the G-code in the next step. So in its most basic form, you just need to check these drop-down options. The print settings is for a 0.3 millimeter trace. That's the only size I've printed with thus far. Obviously a smaller trace will give you higher resolution, but it'll also take much longer to print. Printer settings, SolidDoodle 8x8, that shouldn't really ever change. Those are the only machines we have. So on filament settings, this is kind of an important distinction. We have two different kinds of plastics we can use in the machine, both ABS and PLA. Each one has different settings for the printer, different feed rates, different temperatures, especially temperatures, that they need to be fed into the machine. So be sure you have this setting set correctly. It should tell you on the side of the spool of plastic you're using whether it's ABS or PLA. In this case, let's assume I'm using an ABS spool. So at this point I've got the settings correct. All I have to do is say slice with slicer, and in the most basic form this will go right through and work. I've had some take as long as 10 minutes. I've had most of them take nothing more than 5 or 10 seconds to slice. This one's done in 10. Automatically takes us to the next page, the G-code editor. This is where it shows you actually all the text that Slicer generated, all the machine instructions that will be followed to create your part. All 73,477 lines in this case. Bigger parts will have much, much more. Very last bit tells you how much filament is going to be used, so about 2.5 meters worth. After you start printing, it'll actually also give you a prediction on time, on how long it takes to print. Now, be warned that that time is usually a bit optimistic. It'll take a little bit longer than what it says. So you can see here, if you zoom into the window in the G-code editor, it'll actually give you a preview of what the part will look like, trace by trace. It shows each little cylinder of plastic extrusion in 3D space. As far as I've seen, you can trust this display. If it says you're going to get something weird here, you're probably going to get something strange. Sometimes STL files have problems. They still slice, but there might be a void. There might be additional material where you don't want it. So pay attention. Just kind of give these a look over before you wait 4 hours for a part that isn't what you wanted in the end anyway. So, G-code's generated. Now we just go to manual control. I'm connected to a virtual printer since I don't have a real one here at the video recording computer. So once you've got all those things generated, you can start heating the extruder and heating the print bed. Again, for ABS plastic, the extruder gets up to 215 degrees Celsius. That's the setting. That's the optimal temperature to extrude that plastic. For the print bed, set that at 105. That helps adhesion, helps the plastic stick. One of the difficulties we face in 3D printing, and there are several ways to get around it, which I'll discuss in the advanced video, or one of the advanced videos at least, is how to get the part to stick to the bed reliably so that it won't peel up, it won't deform, but then also don't let it stick so strongly that you can't get it off at the end of the print. So there's a balance there to maintain, and parts peeling up or parts falling off the bed are a somewhat regular, troublesome problem. Okay, so those temperatures are getting up to spec. This is a lot faster on the virtual printer than it is in a real one. This might take upwards of maybe 10 minutes. What you'd want to do in some cases is, once this print head is up to temperature, if you need to change filament or change colors, or change plastic types even, in the spool that's loaded into the machine, this is the time to do it. You have to have the print extruder head heated up, otherwise you won't be able to melt the old plastic out of the print head. You'll just jam everything up and it won't work right. But if you need to exchange filaments, you can simply retract the filament. Click this button a few times, the retract 10 millimeters button. You can set it to whatever you like. You'll see the filament actually retract out of the print head. Once it does that enough, you'll be able to pull the old fragment of filament out. You can load your new filament in, place it through the hole in the top of the print head, and just click extrude, making sure the extruder is up to temperature. And then eventually, once the old plastic gets cycled through the hot end of the print head, just like a glue gun, you'll either see the color change or you'll see that the stream of filament coming out is reliable and consistent. So you can then just grab that junk wasted filament out of the printer area and you'll be primed and ready to go for the print. So at this stage I would recommend zeroing X, home Y, and home Z. These are commands that tell the traverse inside the machine, the print head, to move towards 0 and X, and actually has a little switch on the traverse, on the print head. Then whenever it hits the coordinate that the machine believes to be 0, the switch actually actuates. It's a little feather switch, a little lever guy. Very light force to actuate it. So as soon as that switch actuates, it knows that it's at 0 in the dimension you've clicked on. So homing X, Y, and Z is a good practice to make sure the machine is calibrated correctly. And at this point, you can simply just click Run Job. And you can see in my case, it's going much faster since I'm using a virtual printer, but you can watch the machine lay things down trace by trace, the infill, and it gives you a rough representation of which parts of the print are still warm, which ones are cooling down, based on the color of the print here. Your print won't go anywhere this fast because you'll actually be using a real machine and not one that just exists in the computer. If you start printing and you notice that none of the traces are sticking to the bed, nothing is shaped correctly, it's just not going right, or if you notice that the print head is scarily like messing up the Kapton tape, scratching it, gouging it, that could also be an issue. That means your print bed is not leveled correctly. You need to consult with a TA, consult with a lab supervisor, whoever might be around to help, and they will help you re-level the bed and make sure the print can start appropriately. Getting a good start to the print is essential for having success towards the end. You don't want to wait 4.5 hours out of a 5-hour print just to have it pop off the bed in the last 10 minutes. So make sure you have a good foundation, because without it, it's not going to be a very fun time.